Hello mortals, guess what happens when you divide something by 0? You are right, you get a black hole. And that's what we are going to speak about. Some of them are tens of billions of times more massive than the Sun, while others, smaller than atoms. Right now, you are being held on the surface of the Earth by its gravitational attraction, which is kept in orbit by the Sun, which, together with the whole solar system, orbits the galactic center of the Milky Way, which, in turn is kept together by Sagittarius A, a supermassive black hole 40 million times more massive than our Sun. In fact, almost all galaxies have black holes at their centers, which are vital for their formation. Stars, they are basically a really big bunch of hydrogen atoms which are constantly bumping into one another and combining into heavier elements, mainly helium, but later also lithium, neon, oxygen and silicon. This process is called nuclear fusion, and the force that is exerted stops the star from collapsing in itself. However, after some billion years of nucleosynthesis, the star starts to produce iron. And that's when you know it's gonna be bad. Stars can't fuse elements heavier than iron, and because of the lack of force generated by nuclear fusion, gravity starts to take over. Small stars like our Sun will expand, become a nigger-red giant and probably eat Earth, and then collapse down to a white dwarf, the size of a planet. He's like, if I die, you come with me. However, stars that are more massive will start to shrink, increasing in density. Electrons will be forced to combine with protons to make neutrons, and the core will become a neutron star, all in some milliseconds. Because of some complicated stuff, the outer layer is ejected into space, with such an incredible energy, that it can outshine a whole galaxy. All that is left will be either a neutron star or a black hole. If the density of a neutron star is 400 quadrillion kilograms per cubic meter, then a black hole's is infinite, literally. More precisely, that's the density of the singularity, which is the center of the black hole. It also has zero volume, probably. All of the black stuff you see around is called the event horizon, and it isn't black, it's without color, like really. Because of the gravitational pull of the black hole, not even light can escape it, and therefore there is no light coming to our eyes from that region, and an absence of light is black. But hold on, you might say, how can light be influenced by gravity, if it is massless, and by definition, gravity affects only objects with mass? Well, that's what Newton thought. However, Einstein's theory of relativity says that gravity bends spacetime, and even light is affected by that curvature. Also, in theory, anything can become a black hole, if you compress it hard enough. That region is called the Schwarzschild radius. For example, you would have to compress the Earth to 9 millimeters or the Sun to 3 kilometers to get a black hole. Okay, back to black holes. Once stars turn into them, what then? Do they roam the universe hunting for different celestial bodies to eat? Do they live forever? That's what everyone thought until Stephen Hawking's discovery of Hawking radiation. Basically, in the vacuum of the universe, due to quantum effects, there are virtual particles constantly appearing and at the same instant annihilating each other, and therefore no energy or matter is created or destroyed. These particles have opposite energies and don't affect the outside world and during their small life, hence the name, virtual. But right at the edge of the black hole, these pair can appear, and one particle is pulled in the black hole, while the other one is ejected into space. This breaking of the particle-antiparticle bond results in the black hole losing energy, and thus mass. For a black hole the size of a sun, it would take a time bending 10 to the power 67 years to evaporate, while for bigger ones, 10 to the power 100 years. That's incredible. Just so that you know, the difference between these two is 10 times. Okay, enough with talking, let's jump inside one. But suppose we try and orbit it in a spaceship. As you can see at first, all around the black hole, you can see the light being distorted due to its gravity. All the light coming from the back of the black hole has its path distorted, and in a result, We can see even beyond the black hole, together with its both poles at the same time. As we advance, we are still in a stable orbit. You can observe everything around you having a bluish nuance. That happens because light trying to escape the black hole has a shortened wavelength corresponding to the blue part of the spectrum. As we slowly approach the event horizon, we start to get unstable. We have to use the thrusters of the rockets to keep in its orbit. At this point, we reach the photon sphere, where light itself orbits the black hole. Theoretically, we could see our own rocket by looking at the side, as the light reflected from the ship goes around the black hole and arrives back at us. As you might know, gravity also affects time. On Earth this is unnoticeable, but near such bodies with immense gravity as black holes, time would drastically slow down compared to someone watching you. They would see the spaceship venturing into the black hole. As it approached the event horizon, due to the time dilation, they would see you go slower and slower until you would freeze at the event horizon. Also, light coming from you would get extremely redshifted, and then disappear, as no light could get out. Meanwhile, from your perspective, as you get really close to the event horizon, everything would start to speed up outside the black hole. Your family, kids, grandkids, hundreds of generations will rise and fall in seconds for you. Billions of years will pass while you dive inside the black hole. After you pass the event horizon, this black border, there is no way out. Even if you would travel at light speed, you wouldn't be able to escape. It is literally impossible. If you were falling inside a black hole the size of our sun, the gravitational pull would be way more strong at your feet than your head, and therefore you would be stretched like a spaghetti, hence the name spaghettification. This would certainly kill you, but if the black hole is supermassive, the gravity won't be so powerful, so you might continue your journey for a little more. You would see the borders between the universe and the black hole change with places, and the universe becoming a sphere, brighter and brighter. This happens because all the incoming light would fall forming a circle. It would become smaller and smaller, until all the incoming light would be concentrated into just one point. At this point. But if you were to go further, you would be left with everlasting darkness, no way of getting out. You could say that you wasted your time, all your time that you had, all the time that can exist. Congratulations. Now you are falling to the singularity, the center of the black hole at almost light speed, and as you are about to reach it, outside the black hole, the universe now is an empty space, with no stars in it, as they have extinguished long time ago. Only lifeless planets roaming around together with other black holes that are slowly evaporating. Oh, it's so romantic. In these last moments for both you and the universe, you will reach the singularity. And at this point, nobody knows what will happen, because thanks to these scumbag singularities, scientists couldn't merge the theory of relativity with the quantum theory. But hold on, your journey might yet not be over. If a star that is in process of becoming a black hole is rotating, correspondingly the black hole will be rotating for a little time. This type of rotating black hole is called a Kerr black hole. Because of its centrifugal force, it wouldn't be able to create a singularity. Instead, there would be a ring with no gravity, in which one might survive the tidal forces, and be transported to another place in the universe, or in time, or in another universe, or... This is all theoretical? Yes, there are some complex mathematics behind this Einstein-Rosen bridge, but nonetheless, this might be your best possibility for intergalactic travel. Thank you for your priceless attention, and congratulations, you are now on average smarter than someone who hasn't watched this video, so make sure to share it with your friends so that we can have a better society. Bye bye and see you in the next video.